Good day, students. In this clip, we're going to be going over two examples on how to use the unit circle to find the value of all six trig ratios, okay? So let's go ahead and write down the instruction for the examples. They are as follows. Find the exact value of all six trig functions, all six trig functions for the given angle, okay? And then prove that your answer is correct, that your answer is correct using the Pythagorean identities, which are Pythagorean identities, which are sine squared theta plus cosine squared theta equals 1. 1 plus tan squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. So after finding all six, we're going to use these identities to prove that our answers are correct. All right. So let's go ahead and take a look at question number 1. So for question 1, we are going to be looking for 7 pi over 3. Okay, all six trig functions for 7 pi over 3. So in this case, this is my theta. All right, theta is 7 pi over 3. Now we're going to consult our unit circle, identify 7 pi over 3, and then we use the unit circle ratios to find out what all six values are. Okay, so let's look for 7 pi over 3 here. Look at all the radian measures. We do not have any 7 pi over 3. One easy way we can find out where 7 pi over 3 is by doing something. We know that every angle can be graphed on this unit circle. We just need to keep rotating until we get there. It's kind of hard to work with radians, so I'm going to convert this to degrees and see if that helps us in any way, okay? So what I'm going to do is I'm going to convert to degrees. So 7 pi over 3. To convert this to degrees, I'll multiply by the conversion factor, 180 over pi. Okay? Alright, so 3 goes into itself once, 3 goes into 180, 3 goes into 60 times. So, and then you notice that these pi's cancel out. And then when you multiply across, you end up with 420, supposed to be a degree here, 420 degrees, okay? So now where is 420 degrees here? If we go around full circle, we know that we end up with 360. So it must be 360 and some more degrees, right? So in order to find out what angle is coterminal with 420 degrees, all I'll do is I'll extract 360 from here, which is a full circle. So I'm going to do 420 degrees minus 360. And that's going to give me 60 degrees. Okay, so this point right here, this 60 degrees is coterminal with 420 degrees. So 420 degrees is right here, this point right here. Okay, same as 60 degrees because you go full circle and another 60 will take you to 420. Okay, so what we care about for the angle 7 pi over 3, which is the same thing as 420, are the coordinates 1/2 and root 3 over 2. So it gives us the coordinates 1/2 and root 3 over 2. Okay? Now this is my x and this is my y. Now that I have identified the coordinates, now I can use my unit circle ratios to find all six trig ratios. Okay? So sine theta is y. So sine theta, in this case theta, remember we stated earlier that theta is 7 pi over 3. So sine theta is going to be sine of 7 pi over 3, which is equal to y, and y is this y coordinate right here, root 3 over 2. Okay? Alright, next we need to find its reciprocal. The reciprocal of sine is cosecant 7 pi over 3. Cosecant 7 pi over 3 is 1 over y. We can either reciprocate this, even though if we can refer to our unit circle ratio, it also tells us is 1 over 1 over y. So if we reciprocate 1 over y, we get cosecant. So that's going to give us, we reciprocate that 2 over root 3. We can reciprocate this or divide it by 1, which is the same thing as reciprocating. We can have a squared in the denominator, so we rationalize root 3, top and bottom. So we have 2 root 3 over root 3 times root 3 is root 9, which is 3. Okay? So there goes your first two pairs. Sine and its reciprocal. Now let's go to cosine. Cosine 7 pi over 3. If you look at your unit circle ratios, cosine is the x-coordinate of the point on the unit circle, which is 1/2. Okay? Secant of 7 pi over 3 is 1 over x, the reciprocal of cosine. So if I reciprocate 1/2, I'll end up with 2. Alright, 4 down, 2 to go. Now we need to find, let's look for the tangent. Alright, tan of 7 pi over 3. We know tan is y over x. Consult your unit circle ratios. You can clearly see that tan is y over x. So we have to be really careful here. This is where people make a lot of mistakes. So we're gonna write this horizontally so we do not get confused. Okay, so y is root 3 over 2 divided by 1/2. Okay, when you're dividing, it's the same thing as multiplying by the reciprocal of the denominator, what you're dividing by. So I'm going to change this to root 3 over 2 times 2 over 1. So one common mistake most students make is they forget to reciprocate this, and then they get the wrong answer. Alright? You notice that these two divide out. If you multiply across, your final answer will be root 3. Okay? Alright. Cotangent 7 pi over 3 is simply the reciprocal of tan, which is x over y. If I reciprocate, I can just reciprocate this final answer. I'll get 1 over root 3, because you can imagine that there is an imaginary 1 underneath every number. So there's a 1 under there, so if I reciprocate it, I'll get this, but I don't have to put the 1 there. Now you can have a square root in the denominator, so I'm going to rationalize by multiplying square roots, top and bottom. And then we're going to have square root of 3 over 3. So there goes all your trig ratios. Alright? Okay, now what I'm going to do is I'm going to organize them in a nice list over here. And we're going to prove that our answers are correct. Okay? So let's organize our answers. We have sine 7 pi over 3 is equal to root 3 over 2. Its reciprocal relative, cosecant 7 pi over 3, is 2 root 3 over 3. Cosine 7 pi over 3, whereas cosine is 1/2. And its reciprocal secant 7 pi over 3 is 2. Tan 7 pi over 3 is root 3. And cotangent 7 pi over 3 is root 3 over 3. Okay? Now we have all our answers nicely organized. Now let's see if they are correct. Okay? So what I'm going to do is I'm going to do a check right here. So this is our check. Alright, so first identity I'm going to use is the Pythagorean identity sine square theta plus cosine square theta equals 1. Okay? So on this unit circle, if I take the sine and the square of the sum of sine and cosine of the same angle, I should get 1. So let's see if that's the case here. So for sine, I'm going to replace it with root 3 over 2 square, because that's sine theta, plus cosine theta is 1/2. 1/2 square. So root 3 over 2 square plus 1/2 square equals 1. That's the question. So if I simplify this, root 3 square is 3. 2 square is 4. Remember, the square affects the numerator and the denominator. Okay, this is another mistake most people make. They just do the top. You have to do the top and the bottom. Alright? Plus, same story here. You have to square the top and the bottom. You can have 1. If you square the denominator, you have 4. This is the quotient property of exponents that we talked about before. Is 3/4 plus 1/4 equals 1? 3/4 plus 1/4 is 4/4. 4/4 is 1. 1 equals 1. Answer checks out. Okay? So our first answer, we are now confident that sine and cosine are accurate. Okay? Now let's use the next trig identity, the next Pythagorean identity to verify if another pair are accurate. So the one I'm going to use now is 1 plus tan squared theta. The question is, do I plug in tan into this formula and secant, do I get a true statement? Okay, so tan is root 3, so I'm going to put 1 plus tan squared theta is root 3 squared. Plus, is it equal to secant is 2? Forgot my equal sign. So is it equal to 2 squared? Is this a true statement? Well, let's work it out and see. So 1 plus square root and squares are inverse operations, so they neutralize each other. 1 plus 3, is it equal to 2 squared, which is 4? 1 plus 3 is 4. Is 4 equal to 4? Absolutely. So tan and secant are correct, right? So you're feeling confident now because we've checked off 4. We just need 2 more, and then we're confident that our answer is correct, okay? So the last Pythagorean identity I'm going to implement here to check is, all right, so we're going to have 1 plus cotangent is root 3 over 2, root 3 over 3, sorry, square. Is it equal to cosecant? Cosecant is 2 root 3 over 3, 2 root 3 over 3 square. Okay, let's go ahead and simplify that. We'll have 1 plus, if I need to square the numerator and the denominator applying the quotient property of exponents, I'm going to have 3 over 9. Is it equal to, in this case here, we have to be really careful. This square affects the 2, the root 3, and the 3. Okay, so if I square everything, if I square the 2, I'll get 4. If I square the root 3, I'll get 3. Because square and squares cancel out. If I square the 3, I get 9. Okay, on this right side, we can make this a fraction, find the LCD and combine. But before we do that, let's reduce this right here, okay? So 3 goes into the numerator, divide by 3, and the denominator by 3. So that's going to give us 1 over 1 plus 3 divided by 3, 1, 9 divided by 3 is 3, equals 12 over 9. Okay? Now let's find the LCD here. The LCD is 3, so we times it by 3 top and bottom. And that's going to yield 3 over 3 plus 1 over 3. And then this side right here can be reduced. The greatest common factor of the numerator and the denominator is 3. So I divide the top and bottom by 3. And that's going to give us 4 over 3. On the left side, the denominators are the same, so we just add the numerators. We have 4 over 3 equals 4 over 3. That checks out. That means all our answers are correct. So we're now confident that all the answers are accurate. So cosecant is right and cotangent is right. So we're done showing that all our results are accurate. All right. All right, let's take a look at question number 2. So for question number 2, we're going to be working with question 2, we're going to be finding all 6 trig ratios of negative 855 degrees. Okay? Alright, let's see, where is 855 degrees on a unit circle? We can clearly see that there isn't any 855 here, any negative 855 here. So what I'm going to do is, I'm going to look for positive 855, and then I'm going to use the up or down reflection trick. Okay, so we'll find, let's write out an assignment for ourselves here, find, find positive 855 and then reflect. Okay, find 855 degrees and reflect. Alright, so where is positive 855 degrees? Well, it's way bigger than 360. If I take out a 360 twice, it's 720, and this is even less, greater than 720. So I can take out 2 360s out of 855. So 855 minus 2 360s, which is 720. If I do that arithmetic, 5, and then 5 minus 2, 3, and then 8 minus 7, 1, 135 degrees. So 855, positive 855 is coterminal with 135 degrees right here. So is that the angle I'm going to use? Absolutely not. We need negative 855. So since I need negative 855, what am I going to do? Well, what I'll do is I will reflect downwards, down across, straight down, okay? If I reflect straight down, 225 is coterminal with negative 855, all right? So let's just make a side note here. Negative 855 degrees is the same thing as positive 225 degrees, all right? What we need to extract for 885, negative 885 degrees is this coordinate right here. So we need negative negative root 2 over 2 and negative root 2 over 2, okay? Now, this is the x coordinate and this is the y coordinate. Now what we're going to do next is we're going to start using our unit circle ratios to generate all 6 ratios, okay? So let's start out with sine. Sine theta, in this case theta is negative 855. So what is sine negative 855? Well, it's a y coordinate, right? And the y coordinate in this case is negative root 2 over 2. Let's look for the reciprocal relative cosecant. Cosecant of negative 855 is a reciprocal of sine, or 1 over y. So all I do is I reciprocate this, I'll have negative 2 over root 2. Okay, you cannot have a square root in the denominator, so we need to rationalize. So root 2, and then this is going to yield negative 2 root 2 over root 2 times root 2 is root 4, which is 2. We can now divide out the 2's. 2 goes here 1, 2 goes here 1, and your final answer is negative root 2. Alright, let's look for the next set, cosine. What is cosine of negative 855 degrees? If you look at the unit circle ratios, you find out that it's the x-coordinate, okay? What's the x-coordinate of the point we just found? It's negative root 2 over 2 also. Okay, so there goes the next one. Now let's look for its reciprocal trig function relative. Secant of negative 855 is 1 over x. So it's the same thing as, it's going to be exactly the same answer as this one right here, okay, because they were the same answer question. So if I reciprocate negative root 2 over 2, this whole procedure will take me to negative root 2 because they're identical. Now tan, what is tan of negative 855? Well, that is, if you look at your ratios, consult your unit circle ratios, tan is y over x. So y over x, we're going to have y, which is negative root 2 over 2, divided by x, negative root 2 over 2. Okay? Now, when you're dividing fractions, you have to multiply the numerator by the reciprocal of the denominator. So we're going to drop, change this to times, and reciprocate this or flip it, negative 2 over root 2. Alright? The 2's divide out to 1. The minus and the minus, slash and dash, times 2 become positive. This root 2 goes here 1 and this root 2 goes here 1, so everything divides out. So your final answer for tan is simply 1. Okay? Now the reciprocal relative cotangent of negative 855 is x over y. I can do this work again, but I know that if I reciprocate this, that's a shortcut. The reciprocal of 1 is 1. 1 is its own reciprocal. Alright, so there goes all my 6 answers. Now I'm going to organize them in a nice list on the left side here, and I'm going to do a check to make sure that they're all correct, okay? So I know that sine of negative 855 is negative root 2 over 2. Cosecant of negative 855 is negative root 2. Cosine of negative 855 was the same as the sine, which was negative root 2 over 2. And that meant that a secant of negative 855 was the same thing as a cosecant, which is negative root 2. And then our tan of negative 855 is 1. Likewise, cotangent of negative 855 which is also 1. Alright? Okay, now our answer is correct. Well, we don't know. We have to check. So let's do our check right here. So the first Pythagorean identity I'm going to use to check is sine squared theta plus cosine squared theta equals 1. Okay? Alright, let's go ahead and check that. So sine theta is negative root 2 over 2. So I'm going to put it right here. Negative root 2 over 2 squared plus cosine theta is negative root 2 over 2. Negative root 2 over 2 squared. Is it equal to 1? If I simplify the left side, do I get the right side? That's the question. So if we work it out, we'll get negative root 2 over 2 squared is going to be 2 over 4. Because this minus becomes a positive, and square and this square will cancel out, plus this becomes 2 over 4 also. Is 2 over 4 plus 2 over 4 equal 1? 2 over 4 plus 2 over 4 is 4 over 4. Is that equal to 1? 4 over 4 is just 1, and 1 equals 1. So that checks out, tells me sine and cosine are accurate. Okay? So we can check our sine and our cosine. 2 down, 2 to go. Now let's go ahead and apply the next Pythagorean identity. To check the next pair of three results we got. Identity I'm going to apply right now is 1 plus tan squared theta. Is it equal to secant square theta? Okay, that was a question. Let me partition the workspace here so we do not get confused. Down a little bit. Okay, so let's do it. So we're going to do 1 plus tan theta is just 1. Is 1 plus 1 squared. Secant theta is negative root 2 squared. Is this a true statement? Well, let's work it out. Is 1 plus 1 root 2 squared equals 2? 1 plus 1 is 2. Is 2 equal to? Absolutely, so that checks out. So that tells me that tan and secant are correct. Okay? So tan and secant check out. Tan and secant. Oh, well, I could do it right here. So we already checked sine and cosine. Tan and secant, we just need to do cotangent and cosecant next, okay? So the next equation I'm going to use is 1 plus cotangent squared theta. Is it equals cosecant squared theta? Alright, let's plug it in. Is 1 plus 1 squared equals cosecant theta is negative root 2. So negative root 2 squared, is that the case? Well, let's work it out. We have 1 plus 1. Negative root 2 squared is just 2. So is 2 equal to? Absolutely. So our last pair of trig ratios work out. So we're confident that all our 6 trig ratios we got for negative 855 work out. Okay? So there you have it. Thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. More videos can be found on MyGreatServe.com. Thanks again.